Okay, so now we have we're looking at the integer knapsack problem, where we have n items 1 through n of value 1, v1, v2, v3, vi, vn, and then they are of weight w1, w2, w3, wi, wn. So we want to pack all or a subset of these n items into a knapsack of weight w, right? And here we can have only integer weights, which means all these weights that are given here are integers, so we cannot break any item. So we can either take an item or we can only leave an item. Okay, we cannot break it up. All right, so that's why it's also called a 0-1 knapsack problem. You either take an item or you leave the item completely. All right, and if you take an item, you take the item completely, you don't break it. All right. So the way we do that, this is, we will consider putting in subset of items 1 through I, which means start with I equal to 1 and see if you can put it into the knapsack of weight 1 through W, and then start with items 1 and 2 and see if both of them or a subset of them can be fitted in the knapsack of varying weights 1, 2, 3 up to W, and so on 1 through I in general. On a knapsack of weight 1 through 3, actually you can put your J over here. Okay. Alright, so in general we can write the recursion. So if f of I comma j, or c, I believe c of I comma j is the value of the thing that we have collected, make sure it is c. Yep. Alright, so now when you're looking at item I, you can either leave item I or pick it up. If you pick it up, right, you're going to add a value vi, but so you're bringing in item I and putting it in a knapsack of capacity j pounds. So item I weighs wi pounds, so the remaining portion of the knapsack that weighs how much? J minus wi pounds, okay, has to be researched to see whether you can fit in items 1 through, can be used to fit in one or more items 1, 2, 3 from 1, 2, 3 so on up to I. Okay, so the remaining items can 1 to I minus 1, because you're already putting I over here, so item I is going here. So the remaining items 1 through I minus 1 have to fit in within, or a subset of this. You cannot put everything if the weight is not going to accommodate. So one or more of these items 1, 2, 3 up to I minus 1 have to be fit into this knapsack, or remaining portion of the knapsack of capacity j minus wi, because item I weighs wi. So the weight of the knapsack then is thing is going to be vi plus whatever you have collected based on items 1 through I minus 1 on a knapsack of capacity j minus wi. So this is what you have if you're going to put item I, okay, on a knapsack of capacity j. The other option is to not put item I. So if you don't put item I into the knapsack of capacity j, the whole of j is basically available for items 1, 2, 3 up to I minus 1. So it's going to be the value up to items 1 through I minus 1 comma j, right? So you take basically the maximum of these two. Okay. Now remember, we can put item I into the knapsack only if what? If item I, Wi, the weight is less than or equal to J. If Wi is more than J, you cannot put it into the knapsack, right? So this means if this means also we can say J is greater than or equal to Wi, right? And that implies telling J minus Wi greater than or equal to 0. On the other hand, if J is less than Wi, right? So which means if J minus Wi is less than 0, then we can say C of I comma J is simply, because as I said, if J minus Wi is less than 0, J is less than Wi, which means item I weighs more than J. So all you can do is just put in this items 1 through I minus 1, whatever we can fit in, into a knapsack of capacity J. Right? So that's what we can do. Right? So this is going to be the recursion, and how are we going to fill it up? So either for a given cell I comma j, you basically consider the one above that cell. So for a given cell I comma j, you consider above the cell, the entry above the cell, which is going to be what? Which is going to be I minus 1 comma j, or the same row I minus 1th row, consider a cell which is going to be, so this is going to be this cell, consider that is Wi columns to the left. So J in the column J minus Wi, the same I minus 1th row, right? So here we are going to consider basically I minus 1, the cell I minus 1 comma J minus Wi. Okay, so plus you see the recursion. This is what we are having, the value over here, plus of course what is that we are going to add, sorry, plus the value of item I. Okay, so whatever is here plus the value of item I, or just compare with what is going to be in this cell, right? The maximum of them. If J is going to be less than Wi, which means Wi cannot fit within J, then we cannot consider this, because we cannot go to the left beyond 0, right? Column 0. So then it becomes, we have to just duplicate or enter the same value you have for I minus 1 comma j for also I comma j. That's what it says. C of I comma j is C of I minus 1 comma j, right? So again let me repeat. So if we want to compute the value for the cell I comma j, okay, it depends on whether you are putting item I into the knapsack of capacity j, where j can be anything from 1 to w, integer weights. Alright, so you are proceeding based on the integer weights, right? Okay, so there are two scenarios. You can put item I, or you cannot put item I. You can put item I, again the minimum requirement to put item I is what? Item I should weigh at least j, and that's what is captured by this. When I say item I should weigh at least j, what I mean Wi has to be greater than or equal to j. That implies what? That implies j has to be less than or equal to Wi, right? Sorry. Sorry, if I want to put item I into the knapsack of capacity J, Wi has to be less than or equal to J because it has to hold within that bag, right? I'm sorry, so this is what is right. So this implies what? J has to be greater than or equal to Wi. So if only this is true, okay, item I can be, maybe, or can be is better, can be put in the knapsack, on the back, right? So the minimum condition is item I should weigh less than or equal to J. If item I weighs more than J, we cannot put it in the back. Now, if item I weighs greater than J, that implies what? J is less than item I, then I cannot be put in the back even if you want to. So that's what is captured by this. J less than Wi means J minus Wi less than 0. J greater than equal to Wi means J minus Wi is greater than equal to 0. So if this is true, if J minus Wi is going to be greater than or equal to 0, then we can either put the item in the bag or not, depending on whether you're able to maximize the value. So if I want to put it in this cell I comma J, if I put item I into the knapsack of capacity J, I am left over only with capacity J minus Wi. Within that capacity J minus Wi, I have to see if I can put one or more of these items, 1, 2, 3 up to I minus 1, the remaining items from 1 through I. You put item I, so the remaining items are 1, 2, 3 up to I minus 1. So you want to see if you can put one or more of these items in the capacity bag of capacity J minus Wi. So whatever you carry from there of capacity J minus Wi with items 1 through 3 up to I minus 1 or a subset of them, that's this value. Plus the value carried by item I is Vi, so Vi plus this. You either prefer that or you prefer just this, which means you don't put item I in the bag, you just put, you don't put item I in the bag, you just put what? Items, one or more of items 1 through I minus 1, and the whole capacity J is available. So that's only two possibilities you have. And you will prefer the maximum of these two possibilities, right? Because you want to maximize the value of the items collected in the bag, right? So in order to do that, so you basically compare the entry above the cell I minus 1 comma J, and then the entry, so compare this with an entry which is Wi columns to the left, because all these are integer weights increasing by 1. So Wi columns to the left, so you're basically looking at column J minus Wi, the same row, the previous row above I, which is I minus 1. So whatever the value is here, plus, because now you're going to add item I, right? So item I plus the value of this column. So that compared with this, you choose the maximum, right? So let's do this example. All right. So we are given, say, this list of items of the 4 items, and their weight is 1, 2, 3, 4. So 2, 1, 3, 2, and this is item numbers, and the values are given. So you want to pick one or more of these items, such that the total weight of value of the items, the total value of the items that you pick up is the maximum, and you cannot break any item. Okay, so it's either 0 or 1. You pick an item or you do not pick an item. You do not break it like the other one which we did in the greedy strategy chapter is a fractional knapsack problem, right? So I have this table where I have listed the item weights and their values and the item numbers 0, 1, 2, 3, 4. 0 means nothing. Now what is the basic condition for this? If you don't have any item, right, and whatever be the value of the knapsack bound, you cannot put anything, right? So Z of 0 comma J is going to be 0, for all j, and C of I comma 0 is going to be 0 for all I, which means you may have any number of items, but if you don't have the bag to put in, which is 0 pounds, then you cannot put anything, right? So the value of the items you collect would be 0, right? So let's do it like this. Okay, so the initial condition is going to be something like this. So you have 0, 0, 0 for this column where you don't have any, basically the bag cannot hold anything, whereas this zeros means there is a bag of capacity 5, which is the maximum capacity available for the bag, but you don't have any item to put, right? So that's also the same thing for the history table, right? Okay, so now we are trying to fill up this first row. Of course, you can do it both row or column wise, so we'll just do row wise. So we want to see what this should be here. So take this value, the immediate top, and then what you have to take depends on what item you're considering. You're considering item 2, which is of weight 2, and looking at capacity j equals 1. Remember what I said, j has to be greater than or equal to wi, right? So if wi is going to be greater than j, which means j is less than wi, that's what we have here. J is 1, wi is 2, just write that value. Alright, so then we have j is 2, wi is 2, which is w1 is 2. So now you can at least compare them. So you're going to compare this 0, the immediate top, with 2 columns to the left, which is this column and the same row. So this 0 plus this value 12, which is 12, compared with this 0, that's going to be 12. And how did you get this 12? So the maximum of this or this plus 12, right? So this is C of 0 comma 0 plus item 1, which is W1 that you picked. So you record the history like that. Similarly, the maximum of this cell or 2 columns to the left, which is this cell, plus a 12. So you got the maximum from this 0 plus 12, so which is C of 0 comma 1 plus W1. Now you consider the maximum of this cell or 2 cells to the left, which is this, plus 12. So 12 plus C of 0 comma 2, which is this. And so then you have this or 2 columns to the left, which is 0 plus 12. So you got it from 0 comma 3 plus item 1. Alright. So now let's compute this. Okay, the second row. So you're trying to consider including item 2. So it is either the immediate top 0. Now first you have to look whether j is going to be greater than or equal to wi. J is 1, w2 is 1, so you cannot start comparing. So we can include the 0, or how many columns to the left? W2 is 1, so 1 column to the left, which is this 0, plus this 10, so that's going to be greater, so 10, so you're including C of 1 comma 0 plus item 2, which is W2. So now we want to decide about this cell. You're comparing the maximum over here, the 12, plus 1 column to the left, which is this 0, plus this 12, plus this 10. So 0 plus 10, the weight of item 2 is going to be 10. So 0 plus 10 is 10, is going to be less than this 12. So which means we have to put this 12, and we got this from just 1 comma 2, this thing. We didn't go to the left and add the weight of item 2 or the value of item 2. So we just use the value that we have from here, C of 1 comma 2. Now to fill up this entry, it's basically the value here, or again 1 column to the left, which is this 12 plus this 10, which is 22. So that's going to be the greater one. So we are going to put C of 1 comma 2 plus the item 2. Then over here again this 12 compared with 1 column to the left, 12 plus 10, which is 22. So you're going to put C of 1 comma 3 plus item 2. Again this 12 or 1 column to the left, 12 plus a 10, 22. So C of 1 comma 4 plus W2. Right, so now we are going to fill up this one. You see here J is 1, the third item, W3 is weighing 3 pounds. So j is less than wi. So what you keep doing, you just write the top value. You can start putting the item only if j is greater than or equal to wi. So here j is 1, w3 is 3, so you just write this 10. So you got it from c of 2 comma 1, just immediate top. Similarly, j is still 2 and w3 is 3, so it has to be at j has to be at least 3. So you write this 12 and this is c of 2 comma 2. So now you see here you have 22, and what is that you have to compare? This 22 with something that is 3 columns to the left. Why? Because w3 is 3. So this 22 with something 3 columns to the left, which is 0, plus a 20, which is 20. And 20 compared with 22, 22 is greater, so you got it from just immediate top, so c of 2 comma 3. Now what about this one? You compare this 22 with 3 columns to the left, which is this 10 plus a 20, which is 30. So you got it from adding c of 3 comma 1 plus this item 3. So c of 2 comma 1, this is when we got it right. 10 plus a 20, so c of 2 comma 1 plus an item 3. Now what about this one? So you compare this 22 with which 2 columns to you have w3 is 3, right? So 22 is here, so 3 columns to the left, which is this column, because w3 is 3. So 3 columns to the left, which is this one. Compare this 12, the top 12, with this 20, you will get 32, and 32 is greater than 30. So you got this 32 by going with c of 2 comma 2, this cell, plus item 3. Okay, so let's do the last one. So we want to fill up this, and item 4 weighs 2 pounds, and this is j equal to 1, so j has to be greater than or equal to 2, right? So you just write it as it is and write it as c of 3 comma 1. Now we can do at least some comparison, because j is 2 and item 4 weighs 2 pounds. So compare this 12 with what? J is weighing 2 pounds. Sorry, item 4 is weighing 2 pounds. So 2 pounds to the left, which is this 0, plus a 15, which is 15, and it is greater than 12. So you will use c of 3 comma 0 plus item 4. That's what I showed here. Now about this, you will either hold on to this, or how many columns to the left? Item 4 weighs 2 pounds, so you go 2 columns to the left, which is this 10 plus 15, which is 25. So you got it from 3 comma 1 plus item 4. Now what about this? You take up this, compare with 2 columns to the left, which is this 12 plus 15, which is 27. So 27 compared to 30, 30 is greater, so you write just this 30 and you say c of 3 comma 4, it came from here. And then what you do, you compare this 32 with 2 columns to the left, which is 22 plus 15, which is 37. So you got it better by going through c of 3 comma 3 plus item 4. Okay, so at any time you decide between these two options, which two options, either something like this or c of 3 comma 4. It depends on the cells. So in general it is this. Okay, so for item I for the cell I comma j, go to the top cell, immediate go to the top row, right? That's what it is. Take the immediate upper value, which is I minus 1 comma j, the cell I minus 1 comma j. Compare the value in that cell with the sum of the value in the cell I minus 1 comma j minus wi plus the weight of item I that you are trying to currently add. Okay. So if whichever is greater, you go with that option. Okay. So how do you really decide on which items you have to select? So this is our final solution, that's 37, so that's corresponding to this cell. So it really means that we have to start with this W4 and see what else we have to do, right? So pick item 4 and then you see C of 3 comma 3. So it means go to this row 3, column 3, it says C of 2 comma 3. So go to row 2, column 3, which is this. it says pick W2. So you already picked W4. Now you're picking W2 and go to cell 1, 2. 1, 2 is this. So you pick W1 and go to cell 0, 0, which is going to be this. Right? So the 3 items or in this example you're going to pick only 3 items out of the 4 items. So they are going to be W1, W2 and W4. So you have their weights and the values you can verify. So W4 is $15, W2 is $10, that's 25, plus W1 is $12, so that is 37. Okay, so this is the dynamic programming version of the integer knapsack problem. Now you can also do a greedy version of it, which is what we did in class also. So let me see if I can pull up that. If you remember this example, so for example you are given here 5 items of values and pounds. So greedy strategy is more easy. It is going to give you the best solution because you can divide an item or break up an item, or basically work with fractional numbers, whereas the dynamic programming that we just did, we can work only with integers. Okay, so that's why the dynamic programming thing is called the 0-1 knapsack problem, whereas this is called the fractional knapsack problem. Okay, so how do you do this? You find the value per weight, value divided by weight, which means the dollars per pound, how much value you're adding to the bag per pound of item that you're adding to the bag. So given I'll give you these 3 things, you have to compute the value per weight, which is with all these numbers, and then go with the greedy approach of picking the items in the order of the decreasing order of value per weight. So this is the item, this is the, which one? This is the item that you will pick first because it's the largest, it's having the largest value per weight. So it's going to come up with weight 1 pound. The knapsack has weight 6 pounds, and the value added is $15. So the next value could be either this 10 or 10. So break the time by going to the item with the lowest number, which is 2. So you enter 2 pounds of item 2. So that is going to be 10. You are going to put 2 pounds. So already there is 1 pound. So 2 more pounds, so 3 pounds, and the value is going to be 20. So 20 plus 15, 35. And so then you could pick anything you want. So you could pick this 10, so that's item 4, and it weighs 4 pounds. You see here you cannot pick all the 4 pounds of this because you have picked already 2 pounds here and 1 pound here, so it's 3 pounds totally, and you have only 3 more pounds left, so you have to really break it up. So you can break and take 3 out of the 4 pounds here, and the corresponding value is also assumed to decrease proportionally. So 3 out of 4 parts of this item will value what? $30. 3/4 of 40 is $30. So 30 plus 15 plus this 20, which is going to be 65. So that's the value of the items that you have collected, and the items that you have collected are complete version of item 3, complete item 2, and then 3/4 of item 4. So that's what you have to state in the solution. Okay, work it out.